Welcome to Garrett ComSci. This course is AP Computer Science Principles using the Code.org curriculum. This is the beginning of Unit 1, Digital Information. Here's the list of lessons in Unit 1. First, we'll just be getting started in the course, and then we'll talk about the concept of information, and then we'll scoot toward the concept of binary numbers, which is the system we use to represent information in the computer. Then we'll look at some of the complexities and complications of using binary numbers in the computer in Lesson 5. Then we'll look at various types of information that we store using binary, like text, black and white images, color images. Then we'll look at how to store various types of information in less space using compression. And finally, we'll look at some of the legal concerns about the ownership of digital information and intellectual property. So in this lesson, we'll look at the first two lessons. There's not a ton to talk about here. They're mostly introductory. So let's dive in. Lesson 1, Welcome to CSP. Your teacher may have you do this activity called a rapid prototype, where you quickly design the concept for a new innovation or invention that might improve on something that exists or come up with a new idea to solve some problem in the world. We'll be looking at the concept of innovation, especially computing innovations, throughout the year. There's also this video toward the end that you may see in class. If you don't see it in class or you'd like to watch it again, you can go to your Code.org login and go look at Unit 1, Lesson 1. And I want to show you real quick how you can get to lesson resources like videos that you might see in your slides. So if you go to Code.org, Unit 1, you'd probably see a screen like this. This is your progress through the various activity levels in that unit. If you go to this button right here, you can see a button called Lesson Resources for each lesson. If you click on that for Lesson 1, you're able to see that video that's shown in the slides. So pretty much anytime there's a video, or an extra activity guide or rubric or any extra resources like that, they're likely to be linked in this Lesson Resources button. Okay, let's go back. That's the end of Lesson 1. Now Lesson 2 is representing information. So the first question is, what is your definition of information? You can think about that on your own. There are many ways to express it, but you might say information is the answer to some question. The answer to a question might be one out of several choices, like a multiple choice. It might be true or false, yes or no, some direction like north, south, east, or west, or left, right. It might be a number, like what is your age? So they're all different types of information, and we want to be able to represent those in the computer, to hold on to pieces of information and transform them and do things with them. So the activity for Lesson 2 asks you to take some everyday items like colored pencils and sticky notes and maybe paper clips, all kinds of different things that you could use for this. And you're asked to think about a question that has two possible answers. So some of those I mentioned earlier could work, like a true or false question, or yes or no, or up or down. And then you use the classroom supplies, whatever you'd like to use, to communicate your answer to that question. So remember, we've got a question that is perhaps true or false. So America declared independence in 1776, true or false? And we would be able to show true using one way of perhaps the direction that one of our items is pointing, or how it's being used. Like if it's a pair of scissors, it could be either open or closed. Perhaps a pencil could be oriented up or down to mean yes or no, respectively. Question 2 says, think of a question to which there are 4 possible choices. So maybe a test question could have A, B, C, or D as the answers. So how could you use your items that you have available to you? Let's go with a pencil. How could you use a pencil to represent 4 different possible choices? Perhaps with a pencil, you would want to use just the orientation of the pencil once again. This could be A, pointing up. This could be B. This could be C. And that could be D for the different, for the different answers to the questions. Okay, well, let's think about a third challenge in which there are 8 possible choices. Would our pencil still work in the way that we've been using it? Would it still work nicely to represent 8 possible choices? Maybe 8 could be, the divisions, the directions on a compass rose, talking about the directions: north, northeast, east, southeast, south, and so on. 8 of those. Well, we of course could have our pencil, pointing in all of those directions. But what do you think about that? Is that starting to get a little bit tricky? We could have our pencil pointing in all of those different directions. 1, 2, 3, 4, 5, 6, 7, 8 different options. That might work, but as soon as we add more than that, it starts to get pretty tricky, and even this might get a little confusing. See how close those look. So what could we do instead? So think back to the simplicity of the 2 option possibility, where we just had a pencil pointing up or down, where the lead of the pencil points up or down. That's pretty simple, pretty tough to get confused. So instead of adding a different direction for our pencil to point with every new option for the answer to a given question, could we just use those 2 options in some way? Perhaps we could have more than one pencil, and each pencil is either up or down. So for example, if we wanted something with 4 options, perhaps one pencil could point up and one could point up, and that's option 1. And one could point, so maybe that's letter A in our ABCD challenge. And one could point up and one could point down, and that's B. And one could point down and the other up, and that's C. And then one down, and that's D. So in this situation, we've got a series of just 2 options, up or down, and they're side by side, and the combinations of those 2 orientations makes for all of our options. So if we just had one pencil pointing either up or down, one pencil up or down, that makes 2 options. If we had 2 pencils pointing either up or down each, that's 4 options. If we have 3 pencils pointing either up or down, that's 2 to the power of 3 options. That is 8 options. So every time we add a pencil that either points up or down, just 2 options each, that's doubling the number of options we can represent, the number of combinations that are available to us to represent various pieces of information. Maybe you see where this is going, but we'll pick up with it in the next lesson to get all the way there. So this is the end of lesson 2. We've covered lessons 1 and lesson 2. Go back, and if your teacher has asked you to, and even if not, go look at the Check for Understanding questions on your code.org login and see if you can answer those questions well. I'll see you back for Unit 1, Lesson 3.